new chapter, new day. Woo! Good stuff. Okay. Now, there's a red word on there that scares some people. And scares people. Okay. Proof scares people, but don't worry. Proofs in trig different than proofs down the hall, down the ramp. What? Okay. So we'll shift our emphasis more towards theory and proof, exploring where the properties of these special functions, trig functions, lead us off with no immediate concern for the real-world relevance at all. Okay. I love this next paragraph. We hope in the process to give you an appreciation for the rich and intricate tapestry of interlocking patterns that can be woven from the 6 basic trig functions. Patterns that will take on even greater beauty later on when you view them through the lens of calculus. Poetry. It's good stuff. Deep. Good thing we're on the 2nd floor. So deep. Okay? Let's do this. So, we need to refresh our memories of the 7 big trig identities. Now, can I borrow this for a second? Thank you, my dear. In the first semester, we gave each and every one of you a pink cardstock piece of paper like this. Okay? I would strongly encourage you this chapter to find said pink piece of cardstock and have it with you at all times and in all places. Okay? Because we are going to be referencing this mucho times. That means many times. In the Spanglish, it is this. Okay? So cosine is equal to cosine. We know that. That's a deal. Sine is equal to sine. We know that. Okay? Secant, 1 over cosine. Tangent, sine over cosine. Cosecant, 1 over sine. Cotangent, cosine over sine. The 6 basic trig identities. Okay? And then the big one, the hammer, if you will. Okay? The hammer of sine squared plus cosine squared is always equal to 1. Okay? We're going to have to know those extensively. Okay? So now let's take the hammer and let's divide the hammer by sine. Whoa, that didn't help out. I wanted that gone. See this thing, this circle thing? I don't like it there. I don't like it. It only shows up in this room. So we're going to take the, tap the brakes. We're not going to take that. We're going to take we're going to divide by sine squared. And we're going to divide by sine squared. And we're going to divide by sine squared. Right? What's sine squared divided by sine squared? It's 1. What's cosine squared divided by sine squared? No. Cotangent squared, because they're both squared. What's 1 divided by sine squared? Cosecant squared. So if you're looking on your pink sheet, formula number 7 on the left column has the hammer first, and then it's got the 2 different variations of the hammer. And then if you look up at number 10, you will see 1 plus cotangent squared is equal to cosecant squared. So you just developed formula number 10, or identity number 10, on your pink sheets. Okay. theta, t, that part doesn't matter. Okay. As long as it's an angle, we could even go on x there. Okay. Now let's take the same hammer, sine squared plus cosine squared equals 1, but now let's divide it by cosine squared. Sine squared divided by cosine squared? Tangent squared. Cosine divided by, or excuse me, cosine squared divided by cosine squared? 1. 1 over cosine squared? Secant squared. And this is number 11 on your sheet. So we can manipulate the hammer and get different things out of it. Why, you ask? Well, we're going to be giving you expressions. And we're going to say, simplify that expression until you can't simplify anymore. And then later on, we're going to give you equations. And we're going to say, prove this trig equation. And then later on, we're going to give you an equation, and we're going to say, solve this equation. And it's all going to come out of this kind of a thing. Okay? So, how can I rewrite secant of negative x? Using one of my identities on said pink sheet. What? Okay. Is it? So secant of just x, right? Okay. So that's one way of doing it. We could say, well, this secant of negative x is secant of x, using number 4 on our sheet, right? Another way of doing this one is we could say that secant of negative x is 1 over cosine of negative x, right? Okay. Cosine of negative x. How can we make that look even prettier? Using number 1. Just cosine of x, right? In either case, the answer simplifies down to 1. Secant squared minus tangent squared. Do we have an identity that secant squared is equal to, or that tangent squared is equal to? on our pink sheet, in your notes for today, bless you, do we have something that tangent squared is equal to, or that secant squared is equal to? What? Like what about number 11? Okay, so we could change this to be tangent squared of x plus 1, right? And then we would still have minus tangent squared of x. So that simplifies itself down to be 1. Tangent squared minus tangent squared goes away. We could have also manipulated formula number 11 and gotten tangent squared is equal to secant squared minus 1, and then put secant squared minus 1 in for tangent squared.
The
11, or from the previous slide. Try those two. What would you do in number 3? So that one simplifies down to sine of x. Number 4, what would you do? What are you going to simplify secant to be? 1 over cosine? Okay. Then what? Simplify cotangent to what? Okay. Cosines cancel out. Leaves me with 1 over sine, which is cosecant. We're going to take big, ugly looking things, and we're going to make them all nice and Linzmeyer. Okay? Pretty. Okay. Try those two. There, that's what, 1 over sine. So then when I distribute, I get 1 minus sine squared of theta. 1 minus sine squared of theta is cosine squared of theta, according to formula number 7. 1 minus cosine squared. Sine squared. Cosecant is 1 over sine. That leaves me with sine. Yes? Let's do a couple more. We'll do 2 more. Oops, too far. What's up? Yep.
So sine 2
Sine squared.
Sine squared x. That would like be over 1, so that's why you just get rid of x.
So if you would multiply this out, you would have gotten sine squared of x over sine of x. Yep. Cosecant is what? 1 over sine? Secant is 1 over cosine? Dividing fractions means we flip and multiply. That gives me cosine over sine, which is cotangent. Agree? Still simplifying, but now we might have to do that dreaded F word first. Okay. Looking at sine of x minus sine of x cosine squared of x, what would you factor out? Nope. Nope. Sine. It shows up in both terms. So if I factor out a sine of x, what's left over? If I factor out a sine of x from the first term, what's left over? And a c, what's left over? 1 minus cosine squared. Because what's 1 minus cosine squared then? Sine squared, right? So this one simplifies down to be sine cubed of x. Questions, comments, concerns? Yes, ma'am.
Okay, so when you're doing the factoring sine x, you're taking it out of you're not factoring anything out of the cosine square, right?
I'm factoring sine of x out of x.
So why is this still the same?
Because if you had this? What would you do? Factor out an m, right?
Yeah,
What's left over?
n squared,
1 minus
n squared.
n squared. M is sine, n is cosine.
Okay.
Can't get confused by the x's, because that's part of the sine, part of the cosine. Okay? Good. Try the next one. Factor out cosine squared of theta. Left over,
Just the together.
1 plus tangent squared. Remember, when we factor, we don't lose any terms. We actually gain a term by factor. 1 plus tangent squared is secant squared. Secant squared times cosine squared. Leaves me with 1. Try number 11. Factor out we get Brent? A sine of x. What's left over? Plus cosine squared. Sine squared plus cosine squared? It's 1. It's the hammer. So this one is just sine of x. The nice thing when we get to proving is you'll know that you're right or not. Because you got to prove the other side. So you got to simplify one side of the equation until you get the other side. So you got to keep going until you know when you're done. Okay? Okay? Next slide is just for you. Okay?
He knew. Yeah, he knew. He was like, you're supposed to do this.
It's like Grace can never up time.
Because now, the other dreaded F word. Fractions. Yeah. Yeah. So way back in 6th grade, you learned how to add and subtract fractions. Right? Actually, it might even have been 5th grade. Okay, or even 4th grade. Okay, what? Okay. What did you need back in 6th grade to add and subtract fractions? Common denominators. So this became 15 is my common denominator, right? And then what did you do after you found what your common denominator was? We adjusted, right? So this one would be 5, and this one would be 10. Oh, yeah, 6. Whoa, too much erasing. And then what did we do? Add the numerators. What about the bottoms, the denominators? Kept it whatever the common one was, right? And so we ended up getting 11/15. And then we reduced it if it was possible to reduce. In this case, it's not possible to reduce. Right? Okay. Then you fast forwarded and you got to algebra. Whenever it was that you had algebra. And your algebra teacher said, well, remember back when you were in 4th grade and you were adding and subtracting fractions? It's done the exact same way. First, we find a common denominator. In this case, it's x and x plus 1. And then you adjust the tops. Well, this first one needed to be multiplied by x, and this second one needed to be multiplied by x plus 1. And then they said, add the tops. And then they said, reduce, if possible. Is this one reducible? Is that fraction reducible? Yes or no?
No.
No? Sure?
Yes.
I thought it was 5 over x plus 1. I get 5 over x plus 1. Do they? Or am I being
Not like the
like
numbers.
freshmanish? What?
Doesn't it reduce like 2x in the time?
No. No. Because of that plus or minus sign, we have to factor in order to reduce. Yeah. Don't get into the habit here of crossing those two out. Okay? And then that's how I got the 5 on the top. 3 plus 2. Okay? So now, trig, so now fast forward to, now you're sitting in room 221, it's 10:46 on a Wednesday sunny day. Your math teacher has said that this is the greatest unit ever in pre-calc. He's lying, of course, because we have an even better one coming up in the spring. Okay. And he throws this, add these two fractions together stuff at you. Well, what do? First, you find a common denominator. What's our common denominator between these two? What's the common denominator? Sine of theta times 1 plus cosine of theta. Left fraction, what does it need on top? Needs a sine of theta. Right fraction, what does it need on top? 1 plus cosine of theta. Then what do we do? Found our common denominator, adjusted our fractions, then we add the tops, right? Add the tops. Well, this left top is sine squared, correct? The right top is cosine plus cosine squared. Anything? Can you simplify it at all? Yeah, okay. And that gets me 1. So then this top becomes just cosine. Right? So plus 1? Okay. Because we don't want to lose it, right? It's not multiplication, it's addition, right? Okay. Now what? Yeah, 2 more steps to go. Cross off what? Because this is all together, right? So then that cancels out that. Even though they're written in different ways, right? As long as it's 1 plus cosine, or cosine plus 1, those mean the exact same thing. Yes? Okay. Garrett, put it away. So what does that leave me with? 1 over sine. Which is what, Liz? cosecant. Good times. So we took. This is why I love this stuff. You took this big, nasty looking fraction, and you said, well, duh, that's just cosecant.
Is there a shortcut?
What?
Is there a shortcut?
Yeah.
Oh, what is it?
Well, you first gotta find the common denominator. Then you gotta adjust your numerators. Then you gotta add your numerators. And then you gotta simplify. Yeah. Questions, comments, concerns, clarifications?